Hello Internet, on this video I will try to explain how encrypted communication works in a very basic terms. There are two computers in front of you, the green one is me and the red one is my bank. I'm about to connect to my bank and send some information like login credentials, bank account number. Instead of a bank it could be my file backup storage like Google Drive, Microsoft OneDrive, or a place where I backup photos, tax return papers, medical records, and any other sensitive information. Of course, when I send this information to them, I know that they can see this information, and I'm okay with that because I chose to use their service. For example, if the government wants to see your information, they can contact the bank, Google, Microsoft, or whatever you are using and ask for that information. That's reasonable. Before my information reaches the bank, it has to go through many computers and networks. It first reaches the router that my computer is connected to. It can be a home router or the one in Starbucks where many other users are connected to. Then it goes through my ISP, the internet service provider like Verizon. Then other intermediary networks before it reaches my bank's internet service provider. And only then the bank receives my message. When I say message, I'm talking about any sensitive information that we talked about earlier. Since my message passes through so many companies' networks and their computers, I want to make sure these companies and their employees are not capable of stealing this message. This is why my computer encrypts the message before sending it. In this tutorial, I will call it a lock. To make it simple, only I have the key to unlock my own lock. Nobody else does, and this is very important. So I encrypt my message with my own lock. Let's name it ML, stands for my lock. The message is now locked, in other words encrypted. I will go ahead and send the message now. It passes through my network or Starbucks or wherever I am. It then reaches the internet service provider. If the ISP tries to read my message, or there is a hacker who managed to hack ISP's network I'm connected to and he intercepts my message, they will not see the content of my message because it's encrypted with my lock. The information continues to travel until it reaches my bank. The bank cannot read the message because they do not have my key. So what do? They add their own lock. Let's call it BL, stands for bank lock. Now the message is encrypted with two locks. Then the bank sends the message back to me without reading it because they could not. The intermediary networks or hackers cannot read it either because it's still encrypted. I receive my own message. When I say I mean an internet browser, backup software, or an encrypted app like Snapchat. Once I receive the message, I remove my own lock. Now my message is only encrypted with the bank's lock. So I send it back again. Hackers still cannot read my message because it's still locked, but this time with bank's encryption. The bank finally receives my message. And since it's only locked with their own encryption, they can unlock and read the content. This was a basic explanation of how encrypted communication works. As you can see, it is important that only I have the key for my lock and only the bank has the key for bank's lock. Otherwise, the sensitive information can be compromised. There has been a discussion about adding backdoors to encryption. What that means in simple terms is that the government wants to have the copy of the key that my bank and I use for communication. They will promise to keep those copies of locks safe. The problem is they cannot keep it safe because hackers hack into companies and governments all the time. Hackers can steal the copies of our keys. After that, if hackers intercept my message, they will be able to unlock and read the content. They will be able to do this for hundreds of millions of people who use internet, and that is what an encryption is supposed to prevent. So introducing backdoors and breaking encryption is a bad idea because it threatens the whole internet. I hope you found this interesting. If you did, please hit the thumbs up button and share this video. If you have any comments, please leave your message below. Thanks for watching.